Hi, this is day 2 of solving daily Leetcode problems until I get into Google. Today's DSA problem is find all k distinct indices in an array. So basically we are given an integer array nums and two integers key and k. And our job is to find all positions in the array that are close to the key. Specifically for position I in the array, if there is any other position j where the number at position j is equal to the key and the distance between I and j is less than or equal to k, then I is a k distant index and we should include it in our answer. In the end, return all such indices sorted in increasing order. Let's understand this problem better with an example. Coming to example 1, we are having an array nums which contains 3, 4, 9, 1, 3, 9 and 5. Value of key is equals to 9 and k is equals to 1. Now according to question, we have to find all the indices that are k distinct from any index where the value is equal to key. So first we find all the positions in the array where the value is equal to the key. In this case 9. Let's check the array. So we found that at index 2 and at index 5 we have 9. Now we want to find all indices I such that the value of I minus j is less than equal to k for any of those j's where the nums of j is equals to key. Let's take index 2 where we found our first key. For index j is equals to 2 and k is equals to 1, the valid values of I are 1, 2 and 3 because 1 minus 2 is equals to 1, 2 minus 2 is equals to 0 and 3 minus 2 is equals to 1. So from index 2 we get 1, 2 and 3. Similarly, for index j is equals to 5 and k is equals to 1, valued values of I are 4, 5 and 6 because 4 minus 5 is equals to 1, 5 minus 5 is equals to 0, 6 minus 5 is equals to 1. So from index 5 we get 4, 5 and 6. Now we just combine both these sets of valid indices. From index 2 we have 1, 2 and 3 and from index 5 we have 4, 5 and 6. Putting them together we have 1, 2, 3, 4, 5, 6. This is our final answer. All the indices that are k distance from any occurrence of the key. And don't worry, if number appears in both sets, we only keep it once and everything is in increasing order. Let's see the approach. First we go through the array and find all the positions where nums of j is equals to key. Now for each such index j, we mark all indices in the range j minus k to j plus k as valid. But to avoid duplicates, we use a smart trick, a pointer start. The key idea is to keep the track of the first and last added index so that we don't add the same index again and we process the next key. Let's start the coding now. So let's create a list of integers. Answer is equals to new array list int and is equals to nums dot length int start is equals to 0 for int j is equals to 0 j less than n j plus plus. If nums of j is equals to k, int left is equals to math dot max 0 comma j minus k, int right is equals to math dot in n minus 1 and j plus k, while start is less than equal to right if start is greater than equal to left. Start add start start plus. Let's return the answer. Let's compile the problem. Oh, there are certain errors here. I must have. Oh. Okay, so answer is accepted. Now let's submit the solution. So as you can see, we have submitted our solution, and the runtime of this solution is 2 millisecond and it bits 97.25%. Now let's understand this solution. We first declare our answer to store our result. Int start equals to 0. This pointer helps us to avoid re-adding any index that's already been included. Whenever we find nums of j is equals to key, we calculate the valid window for start index from j minus k to j plus k. We clamp that range to stay in the inside bound of the array. Then we go from start to right. And if we are inside the left comma right, we add that index into the answer. After that, we move start ahead to avoid duplicate entries in the future. Finally, we return answer. The time complexity of this problem is O of n. That's how we solve this problem in the clean and optimal way. Thanks for watching day 2. See you tomorrow with the next one.